Hello and welcome once again to MPhil Physics Tutor. Today we're going to take a quick look at one of the AQA A-level physics questions on capacitors. State what is meant by capacitance of 370 microfarads. Well, we know from our formula Q equals CV that the capacitance is equal to the amount of charge stored per voltage or per volt. Therefore, in this case, we have a charge of 370 microcoulombs being stored on the plates for every 1 volt of potential difference across those plates. To calculate the resistance of R then, we use the fact that the time constant is simply equal to R times the capacitance, and we know that the time constant is 1. Therefore, the resistance is going to be equal to 1 over 370 times 10 to the minus 6, which is equal to 2.7 times 10 to the 3 ohms, or 2.7 kilo ohms. So we need to know, to do this one, what the voltage is going to be on the plates at 2 seconds. To do this, we're going to use the formula that V equals VO, or V0, times 1 minus E to the minus T over RC. So this is the formula for charging up a capacitor. So that means that V out is going to be equal to 9.8, and the time is 2 seconds, and RC is equal to 1. So the V then is going to be equal to 9.8 times 1 minus E to the minus 2 over 1, because 1 is the time constant and 2 is the time. So now it's just a question of bunging the numbers into your calculator, and when you do, that comes out as 8.5 volts. So we now know where our point X is going to go, at 8.5 volts. Now the curve for this mustn't go flat because we've only had a couple of time constants here, so this capacitor is still going to be well and truly charging. So trying to make that gradient not equal to 0 at 2 seconds there. Calculate the time taken for the charging current to fall to half its initial value. Well, for this one we're going to use the fact that T half is equal to 0.69 RC, which is a formula I think you're given. Now remember, this is approximately. So 0.69 times R times C, which is 1, which is 0.69 seconds. And so to the last part, where we have to find out how long it takes for the capacitor to reach 3 millicoulombs. And to do this, we'll use our charging formula for a capacitor, which is going to be 1 minus E to the minus TRC, T over RC even. So Q, that's the capacitive charge that we want to get to, is 3 millicoulombs. To find Q0, all we need to do is just use the formula Q equals CV. We know the capacitance, 370 microfarads, so 10 to the minus 6, and the voltage is 9.8. And that will give us a maximum charge of 3.6 times 10 to the minus 3 coulombs. So remembering that it's best to do the algebra before you plug in the numbers, this means that Q over Q0 is going to be equal to 1 minus E to the minus T over RC. And bringing the 1 over to the left hand side, we get Q over Q0 minus 1 equals E to the minus T over RC. So now we are going to swap this around in order to get rid of the minus sign. So we're just multiplying through by minus 1 effectively. Now we're going to take logs. Natural logs of 1 minus Q over Q0 is going to be equal to minus T over RC. Now we can substitute in some numbers. So that's the log of 1 minus 3 times 10 to the minus 3 divided by 3.6 times 10 to the minus 3 is equal to minus t over 1, because the time constant is 1. Now, if you do the log of 1 minus what I've written there, q over q0, you will actually get a negative number. And that negative number is going to be minus 1.79. And that's going to be equal to minus t. Therefore, t equals 1.8 seconds. Two significant figures.